Good morning, everyone. Myself, Priyadarshini, working as assistant professor in the Degree Department of R&D Engineering College. And today I am going to discuss the topic about DSP processor. And this is the Unit 5 in the syllabus of W859. So, what is the need of a processor? So, the programmable processor, the digital processor, it's a programmable, and it is a called that is it is a general purpose microprocessor and designed specifically for some purpose, that is a digital signal processing application. They contain a special architecture to execute the computation and DSP algorithms efficiently. And the processors are divided into two. One is general purpose digital signal processor, another one is the special purpose digital processor. The general purpose digital processor is they are basically a high speed processor with architecture, and the instruction set is optimized for a certain DSP operation, and they are include the fixed point processor. So the such as the Texas Instruments TMS 320C5X and C54X and Motorola, and the Texas Instruments and then analog devices ADSP 21 series. They intended to run a fully general set of applications and end user programmable for any application. So these are the characteristics of a general purpose digital signal processor. The next is the special digital signal processor. Uh, this type of processor consists of hardware and designed for a specific DSP algorithm such as FFT and PCM and filtering facilities are also available in the special purpose digital signal processor. Examples are the voice echo canceller and FFT processors, and these are the examples of special purpose digital signal processor. And often you are the design time and not end user programmable operates in a fixed runtime constraints. And the next series is going to be the TMS 320 C8 series, and this is the first generation Texas Instrument 32-bit floating point digital signal processor, and it is an easy to use high performance architecture and can be used in a widely variety areas like automotive applications, digital audio and digital automation, everything. And it is an intended multipliers are used, and the size is around 16 million of 32-bit words. The next is of the next generation is C4X series, and it is of a 32-bit floating-point digital signal processor, and it is used for parallel processing. It combines the high-performance CPU and the DMA controller with the six communication ports to meet the needs of a multiprocessor. Once on this, it is analyze a module and supports the hardware breakpoints, and this accepts the source code family of floating point DSPs. The key applications are the three-dimensional graphics or the image processing can be done with this C4 series, and the last advanced generation is 5 series. It accepts the source code from directly before generations itself, and faster cycle operation and on-chip memories are available, and the switching content switching and it helpful in the getting the programming languages. That is, the code can be done by using the programming languages also, and it can be directly optimized in this five series. And this family is of a 16-bit fixed point DSP targeted of high volume and low power application. The first family members are introduced in this of 1994, and the frequency is around 160 megahertz. And in which areas and all we are using the processor in audio applications, in portable audios, in cameras and telephones or storage products we are using, especially in the industrial control side, networking, wireless base station, cable modems and all. We are using the DSP processor. And these are the points why we are selecting the digital signal processor for the applications. Architectural feature, the main feature is an architectural feature, why we are going for that. And the execution speed, type of arithmetic operations we are using, and the word length. The size of the on-chip memory, that is special instructions can be done, and execution speed is very high when compared to the other processor. And fixed point or the floating point can be done. The process can be done with both the things, and number of bit size, the longer word length we are using, and moreover the error can be reduced. There are three types of architectures for the DSP processor: one human architecture, hardware architecture, and very long instruction word architecture. So the first architecture, whatever they have discussed, find it out as one human architecture, and this is the basic architecture which previously they have used. In this, the instructions were stored only in the ROM. That's mostly why used in the majority of microprocessor. And in the one human architecture, the CPU can be either reading an instruction or writing only, that is the data from or to the memory. That is, we can do the work only one thing at a time. That process is not parallel processing. So both cannot occur at the same time. So since the instruction and the data use the same signal path in the memory. The one human architecture consists of the three buses: the data bus, address bus, and the control bus. The general purpose processor have this architecture generally. It shares the same memory for program and data, and the instruction of fetching, decoding, or executing the operation in a sequential manner. It has the data bus and address bus and control bus. Data and instructions are both stored in the main memory itself. The content of the memory is addressable by the location. The next, regarding the three buses, the data bus, as we know, it is used to transfer the data between the CPU and the peripherals, and it is a bidirectional data bus. And the next bus is going to be the address bus to indicate which peripheral, if I want access within each peripheral, which specific register. The address bus is a unidirectional bus. The next is the control bus. It carries signals. It carries the signal to manage all the operations or to exchange the data between the CPU and its peripherals, or it is going to be the bidirectional to read or write on the data. And this is the structure of the one human architecture. And CPU and the main memory has been connected. The data bus as well as the control bus. The data bus is going to be the bidirectional, and this is the control bus. And our architecture consists of a CPU and the clock for the generation of the pulses, and only the memory is that is program or data. It can be accessed for both the program and data. It is not having a separate memory. And next is going to be the peripherals. So each and that bus can be used or only one at a time. If I want to fetch the data, it is used to fetch all the data or read or write operation. So both can't be done at the same time. The next architecture is the hardware architecture, and this is somewhat advanced when compared to the one human architecture, because it will be having a separate memory for the program as well as for the data. And the buses available are separate for the address bus as well as for the data bus. And here also, which program memory is on the side, and the processor, the data memory, and the peripherals. The main thing is the speed of execution is faster when compared to the one human architecture, because it is not necessary to wait for the other bus to go and fetch the data or go and fetch the program from the memory. So the parallel execution can be possible with this hardware architecture. So hardware architecture, this is of the next is going to be the modified hardware architecture. So, and in the modified can be shared by data as well as the programs. And this provides a flexibility in use of these memories. And use the DSP processor normally have this type of architecture. The next modified hardware architecture. The last, whatever we are using is very long instruction word architecture. The main thing is the size of the architecture, the size whatever we are using, it's very high, and the process can be done easily. The parallel processing as well as the DMA access controller, everything is possible with this very long instruction word architecture. The multiple instruction and the simple regular instructions it is having, and combines many simple instructions to give a single long instruction. So the process can be easily done, and the parallel processing are available with this. And this is the very long instruction word architecture. Register file execution unit is separate for each and every registers, and instruction cache and instruction register. So the advantage is increased performance, better compiler targets, potentially easier to program, and it is potentially scalable. The main disadvantage is we are using the increased memory use and the power consumption will be more.